So in this video, we're going to talk about how to find exact roots. In other words, we're going to be simplifying them. And I'm going to compare this to when we have a fraction that needs to be simplified. Okay, so when I look at the fraction 10/16, if you divide that and give me the decimal, the actual decimal is 0.625. If you were to round that, I mean, that's not a completely terrible thing, but if I want an exact answer, that's not exactly what the answer is. Okay, now you're like, well, yeah, I could give you the exact decimal, and you could, but a lot of times we want to keep that answer as a fraction. So what I would say is, I want you to keep this answer as a fraction. Don't turn it to a decimal at all. But you guys all know we would not want to keep this fraction this way because it's not in simplest form. So we would go through the process of simplifying this, dividing top and bottom by 2 to get 5/8. This same idea applies to finding square roots, okay? So, for example, if I ask you for the exact answer of the square root of 8, I do not want you to plug it into your calculator and give me a decimal that you're rounding. This is irrational. You would have to give me a rounded decimal because you can't write it all out, okay? So the exact answer for the square root of 8 is the square root of 8, just like 10/16. If I tell you to leave it as a fraction, it's 10/16, okay? But just like with this fraction, well, yes, that is correct. I want it in simplest form. I want it simplified. We can simplify roots. So yes, the square root of 8 is the exact answer, but it can be simplified. And that's what we're going to talk about. So what you do need is your perfect square poster for this activity. So if you need to pause the video and get that, you're going to have to do that. We need to know our perfect squares in order to be able to do this. So this can be simplified because I have numbers that I can multiply to give me 8. That's what I want. So what I'm going to do is actually split this into a square root of a number times the square root of another number. The numbers that go under here have to multiply to give me 8. 8 and 1, 4 and 2, I mean, those are it, right? Here's the only caveat. Whatever goes in this first one has to be a perfect square. So it has to be a number off of your perfect square list, okay? I hope we all know 4 is a perfect square. So I can rewrite this as the square root of 4 times the square root of 2 because 4 times 2 gives me 8, and this number is a perfect square. Just like with 10/16, in order to simplify that, I have to have a number that I can divide into both. I couldn't divide this by 2 and this by 8. That doesn't work. There are rules that we follow. Okay? Now, we're going to give the answer. What is the square root of 4? The square root of 4 is 2. We know that. This is a nasty decimal, right? Square root of 2 is irrational. So we're just going to leave that as the exact square root of 2. So the square root of 8 as an exact answer is square root of 8, but simplified down is the same thing as 2 times the square root of 2. Okay, now you can plug these into your calculator to check. Square root of 8, look at that decimal, 2 times the square root of 2, and you're going to see that same decimal. Okay? All right, let's try another one. We're going to go through this same process. So if I have the square root of 500, 500 is not a perfect square. If you plug it into your calculator, it is a decimal, it is irrational. So this is the exact answer, the square root of 500. We want to simplify it just like we would a fraction. So I need to rewrite this, and I need 2 numbers that will give me 500, and this one has to be that perfect square. We talked about that. Okay, now if you don't know, that's where you look at your perfect square poster and you look at all the numbers smaller than 500, right? It does you no good to look at 625. We can't take 500 divided by 625. It's not a factor of it. So look at all the numbers less than 500 and find the one that is a perfect square that you can take 500 divided by. Some of you know by looking. Some of you might have to use your calculator and figure it out. But that perfect square is 100. 500 divided by 100 is 5. So if I figure this one out, but I don't know what goes here, I just take 500 divided by 100, and that's going to give me my other number, okay? Now we find the square root. Square root of 100 is 10. That's a decimal, so I just leave it. So 500 is 10 root 5. In its simplest form, exact answer. Okay? All right. So let's go back to fractions for a second. We've talked about how this is like simplifying fractions. If I gave you that fraction, 6 over 3, I would hope you wouldn't go through the entire simplifying process. I hope you would look at this and go, that's just a simple division of 6 divided by 3, which is 2. So 6/3 is just 2. I'm not going to go through reducing and giving a fraction. This is actually a division problem. We'll have that same thing with square roots. Sometimes, if I ask you to simplify the square root of 25, I hope you go, well, that's already a perfect square. The answer is just 5. Okay, so don't go through the simplifying process for numbers that are already perfect squares. This is the exact answer. It's not a decimal. Just say 5, just like you would say, well, 6, that's really 6 divided by 3, so it's just 2. Okay? Also, if I asked you to simplify the fraction 2/3, you would all look at me like I'm crazy, knowing, well, Mrs. Lang, 2/3 is as simplified as it's going to get. You can't simplify that fraction anymore. We have roots like that, okay? That's just going to stay 2/3. If I ask you to simplify square root of 21, well, if you go to your perfect squares poster, the numbers that are the perfect squares that are less than 21 are 16, 9, and 4. Well, I can't take 21 divided by 16, can't take it divided by 9, and I can't take it divided by 4. Yes, I can take it divided by 1, but anything divided by 1 is itself, so you're going to be back at the beginning. Square root of 21 is kind of like the fraction 2/3. This root cannot be simplified, and I know that because when I look at my perfect squares poster and I divide, if I don't know for sure, I'll use my calculator, I can't take 21 divided by any perfect squares and get another factor out. That's not a decimal. So this just remains the square root of 21. That's like a fraction that can't be simplified. Okay? Next, if I gave you this fraction and asked you to simplify it, there are more than one way. We've talked a lot of times with fractions that we might have to reduce more than one. So some of you will say, oh, I see that these are both divisible by 3, which is going to give me 6 over 9. But then we look at this and is this simplified all the way? No, I can simplify this more. I can divide by 3 again. Okay, and that's going to give me 2/3. Some of us realize that we can simplify this in one step if we just divide by 9. You guys know me, I don't care which path you chose, as long as you get to 2/3, right? That's the way it can be with roots as well. So for example, if I say we are going to simplify the square root of 162. Some of you may look at your perfect square poster and go, all right, number times a number, this one has to be a perfect square. 81 is a perfect square that goes into 162. 162 divided by 81 is 2. Square root of 81 is 9, so this answer is 9 root 2. Some of you may not have seen 81. You may have seen, and this works, 9 is also a perfect square that goes into 162. 162 divided by 9 is 18. We have 3 root 18. However, just like with that fraction where I had to divide again, this can be split again. Okay, and we're running out of room, so I'm going to write that up here. Okay, but that can be split again. So I have 3 times the square root of 9 times the square root of 2, because 9 is a perfect square that goes into 18. So now I have 3 times the square root of 2 to get 9 root 2. Whoops. Okay, so I get the same answer, but it was a lot easier if I could find the biggest perfect square. I could do less work. Just like when we are simplifying fractions, okay, it's a lot easier when I have 18/27s to just divide by 9 once rather than dividing by 3 twice. Both ways get me the answer. this was less steps. So my suggestion when you're looking at the perfect square poster is instead of starting at the top of the poster and saying, oh, is it divisible by 4? Is it divisible by 9? Start at the bottom. So when I see 162, the first number I'm going to look at is 144. It's not divisible. 121, not divisible. 100, not divisible. 81, oh, it is divisible. And that way I get the biggest perfect square right from the beginning. And so that is helpful with that. This is one of those things that just, it takes a little bit of practice. And you just want to look at that perfect square poster and see, first of all, is it already a perfect square, like square root of 25? Then your exact answer is just the integer, 5. Is it like the square root of 21 where it doesn't have a perfect square factor, so I'm just going to leave it as the square root of 21? Or is it like this where I can find one and simplify it down?